Hi there. Today is Thursday, September 3rd. September is here, fall is here, and I can't wait for us to get that cool weather. So today we will be learning and discussing the real number system. If you guys remember from last year, you guys did talk about it. You guys just didn't talk about irrational numbers, and that's what I will be adding in today. So today's learning objective is I will classify whole numbers, integers, rational and irrational numbers using a Venn diagram to describe relationships between a set of numbers. So let's review what you guys learned last year about the real number system and some essential vocabulary. So it consisted of natural numbers, whole numbers, integers, rational numbers, and today I am including irrational numbers. We write the numbers in ascending order using braces to show a set. Basically, remember a set is a collection of objects or numbers. Sets are noted by using braces. And remember, a Venn diagram is a diagram consisting of circles or squares to show relationships of a set of data. So let's see, what do you remember from last year? What are real numbers? Real numbers consist of all the rational and irrational numbers. The real number system has many subsets. So last year you guys talked about rational numbers and you guys talked about the subsets, which were natural numbers, whole numbers, and integers. So here to the right, this is the new thing. This is what I will be teaching you today, in today's lesson, which are irrational numbers. Let's review natural numbers. So natural numbers are the set of counting numbers such as 1, 2, 3, 4, 5, and so on. Next, we're going to move on to whole numbers because this is review, so I'm going to go a little fast. Whole numbers that are the set of numbers that include 0 plus the set of natural numbers. So remember with whole numbers, you can include the 0. So 0, 1, 2, 3, 4, 5, and so on. Integers were introduced last year. So integers are the set of whole numbers and their opposites, including all positive and negative whole numbers. So for example, -3, -2, -1, 0, 1, 2, 3, and so on. Now let's move on to rational numbers. Rational numbers are any number that can be expressed in the form of a over b, so it can be expressed as a fraction, where a and b are integers, okay? So they can be whole numbers, whether positive or negative, and b cannot equal 0. So remember, if you guys remember, b is a denominator, and b cannot be 0 because we cannot divide by 0. So examples of rational numbers are fractions, both proper and improper, terminating decimals, or repeating decimals, and square roots that are perfect squares. Now let's begin by discussing rational numbers that are terminating decimals. Terminating decimals are decimals that contain a finite number of digits. So let's focus on this word finite. That means it does end, okay? So it's terminating, the decimal's terminating. So 36.8, 0.125, or 4.5. Let's move on to rational numbers that are repeating decimals. So repeating decimals are decimals that contain an infinite number of digits that repeats with a determined pattern. Now here's the difference between this repeating decimals and terminating. Infinite, that means the decimal keeps going, but it repeats in a determined pattern, and that makes it a rational number. So for example, 0.3333 repeats, or 7.689, it repeats in a determined pattern, so therefore those two decimals are rational. And let's not forget, a line above a decimal indicates that the number repeats. Let's move on to rational numbers that are fractions. So which fractions are considered rational? Fractions that are proper or improper, fractions that are negative or positive. So some examples of proper fractions would be 1/2, 2 3/4, -5 7/8, or -9/11. Examples of improper fractions, this should all be reviewed, guys. 10/3, 203/13, and -23/7. So now let's move on to rational numbers, square roots that are perfect squares. When taking the square root of any number that is a perfect square, the resulting will be a whole number and their opposite. For example, a positive and a negative number. So examples of square roots that are perfect squares: square root of 4 is plus or minus 2. Square root of 25 is a positive 5 or negative 5. Square root of 81, square root of 100, and square root of 169. Those are all perfect squares, so they are considered rational numbers. Now let's move on to the new thing, irrational numbers. So irrational numbers are any number that cannot, notice it says cannot be expressed as a fraction, so A over B. They are expressed as non-terminating. That means they keep going on forever. They never stop. Non-repeating decimals. So all those numbers that keep going on forever and never stop, they don't repeat. Okay? Now here are some examples of irrational numbers. So let's focus on this decimal. Okay, it's repeating, repeating, repeating. It tells me right here, these 3 dots tell me that they never stop and there's no pattern to it. So it's irrational. Let's move on to this one. Okay, 45.86745.893. Okay, it's non-terminating because of these 3 dots and there's no pattern. So that is irrational. And we have talked about pi. Pi is one of those special numbers. Remember, it never ends, it never stops, and it always repeats, and there's no determined pattern. Some of you guys know the first few digits, like 3.14, but that keeps going on forever, so it's irrational. The square root of 2. That is not a perfect square. If you take the square root of 2, you're going to get a decimal, and it's non-terminating, non-repeating, so it's an irrational number. So for your information, when taking the square root of any number that is not a perfect square, the resulting decimal will be a non-terminating and non-repeating decimal. Therefore, those numbers are always irrational. So some examples of non-perfect square numbers or square roots are square root of 2, square root of 23, square root of 30, square root of 55. Moving on, you guys have seen Venn diagrams before, and this is the Venn diagram that we will be using today. If you notice to the left, rational numbers, and there is some subsets in here, and to the right, irrational numbers with no subsets, because they're all on their own. So we will be classifying the numbers A through H, and we will be classifying them as natural, whole, integers, rational or irrational. Okay? So here is how I classified them. So let's talk about it. So now that all the numbers are placed where they belong in the Venn diagram, you can classify each. So let's look at 117. 117 is considered a natural number. It's kind of like a counting number. So it's a natural number because that's inside the rectangle of the whole number. It's also a whole number because the whole number is inside the integers. It's also an integer and it's also a rational number. So that's why I said that it's a natural number, a whole number, an integer, and a rational number. Okay, let's move on to -1/2. That is a fraction. Remember fraction, guys? Fractions are rational numbers, whether they're positive or negative. So it's only a rational number. If you notice, this is the most outer rectangle. 0. 0 is a whole number, an integer, and a rational number. So remember, 0 is not a natural number, so we start at whole number right here. And because it's a whole number, it's also an integer. And because it's an integer, it's also a rational number. Okay, let's move on to -12.64039. That's an irrational number. Let's look over here why I classified it over here. Well, if you guys notice, these 3 dots tell me it keeps repeating. It's not terminating. And if you notice, there's no determined pattern. So because there's no determined pattern and it keeps repeating, it's irrational. Okay, we're going to move on to -3. -3 is an integer because it's a negative number. Because it's an integer, it's also considered a rational number. Let's move on to 6.36. That is a rational number. It's over here. Okay, that is a decimal and it's terminating. It's finite. So that's a rational number only. And we know pi. Pi is irrational. It's never ending and it's a never ending number that does not repeat with a determined pattern. And lastly, we have 4 over 9. That is a fraction, so that is a rational number. Now it is your turn. Please take a moment to try these 7 examples. Try to classify those 7 numbers. Pause the video. Once you have classified them, replay the video, and let's see how you did. Okay, you guys are back. So here are all the 7 numbers. I hope you guys got them right, and I hope that you understand rational numbers much better, and that irrational numbers is starting to make sense. So now what you guys are going to do is you guys are going to move on to the next section and get more practice with irrational numbers and the real number system.